Hello everyone. In this video, we will apply the boundary conditions. As we have discussed, we will apply lateral load and axial load into the scrap tire rubber pipe models. So, as we have discussed, the axial load is set to be 5 megapascal, and the lateral load will be have a strain of 250%. If you see, the overall height of this rubber pit isolator is 24 millimeter, but if we eliminate the carcass layer and bell layers, the equivalent thickness will be 20 millimeter. You can subtract the bell layers dia and from this one, and you will get 20 millimeter. So 20 we have to apply lateral load at a strain of 250%. So 250% of the height 20 millimeter is around 50 millimeter. So that's why we'll apply a displacement here around 50 millimeter. Okay, as this program will be running in non-linear, so the loading condition will be also non-linear. So what is the non-linear condition? Let us go to the next slide. So this is our axial loading pattern, and this is the lateral loading pattern. If at first the axial loading will start, if you see the slide, just this one. Okay, if you see, the axial loading is increasing and will go to 1, and the lateral load is 0. At time 1.6, the lateral axial load will increase to 1, but the lateral load is 0. It means that the whole vertical pressure is coming, then the lateral load will be applied. So if we see the next one, the axial load will be constant at 5 MPa. Right now it is denoted as 1, then will be multiplied by 25 MPa, and this is also 1, but will be multiplied by 50 millimeter. So this is 5 MPa, so the load will be 5 times 1, so it will become 5 MPa. Same goes for this one also. This is 50 meter displacement, so 50 meter times 1, this one will become 50 millimeter. So if we see again, first the load will increase in axial, but there will be no a lateral load displacement, and the peak will be reached at 1.6 second. Then the loading axial load will be constant, and the lateral displacement will start increasing up to 50 millimeter. Okay, so let us define the table first. So let's go to the Marc Mentat. First we have to define that table. So go here, tables, new, 1 independent variable. So first let's define the axial. So the V1 means the x-axis. So the V1 is a function of time. So click time and click add points. So the first point is 0, 0. So 0, 0 space 0, and the next point is 1.61, because at 1.6 second it will reach 100%. So 1.61, and upon 6 second we will give the load around 6 second. So, and at 6 second it will be 1 constant, 6 1, enter. So if we click this one, fit, you can see the same exact curve with this one. Okay, so click OK. Let us define also the lateral load also. So lateral, this is a function of time at points. At 0 the load will be 0. At 1.6 that load is also 0, because at 1.6 second there was not any lateral displacement. Then it will increase up to 6 seconds and it will get 100%. So 6 1 enter. So if you click fit, you will see at 1.6 second that there is no lateral displacement, then it will increase up to 100%. Okay, so let's click OK and click this one. It will show your model. Okay, so let's go to boundary condition, new structural. Let us first define the lateral displacement. So fixed displacement, let's name it lateral, and we'll apply towards x-axis. So what is the table that we had defined earlier? Lateral. So we have said that the lateral table was defined with respect to 1. So if we add below here 50, that means the 50 will be multiplied with the table value. So we are going to apply 50 meter displacement. Okay, so what is the where we are going to apply? So click add node. So here, so click this one, right click. So you can see this is our nodes. You can see in the bigger view. So click this one. This one will be show bigger. Okay, so okay, so we can turn off right now for time instance. So let us give also the axial load. So point load, so let us name it axial. So this one should be 4z, because in z-axis we are going to apply. So 4z, so we have to keep it negative because this is positive, but we are going to apply it downward, so this is negative. So the area is 72 by 72. So 72 times 72 times 5 will give you force. Area times pressure will give you force. That's why can give, if you enter, this one will be 25,920. Then you click add, click the tables, axial, then nodes, this one, right click, you can see the nodes. If you toggle this one, you can see the axial load, but you want to show all the conditions, so you have to go boundary conditions, identify, and you can see this is our lateral load, this is our axial load. So in the next video we will discuss how to set the load case. So see you in the next video.